Hi, welcome to a new lesson of industrial drawing. Today we're going to learn how to draw helical gears. Remember from the last lesson that an helical gear is a spar gear where the edges of the teeth are inclined. Why? The engagement of teeth is gradually and not abrupt. Here you can see a profile view of an helical gear. Let's call the angle of the teeth beta. Then we can get the circular pitch, which is the distance of two consecutive points on the pitch circle. So we can relate. No. So we can get a relationship. No. So we can relate the pitch to the diameter of the pitch circle and the number of teeth. Remember, Z stands for the number of teeth. As a consequence, we get the circular module, the diameter of the circular pitch divided by the number of teeth. But in helical gears, we can get another pitch called normal pitch. We can get the normal pitch by drawing a section with a normal plane to the teeth. We can get the distance of two consecutive points over the circular pitch and we call it normal pitch. So we can relate the normal pitch and the circular pitch by means of the cosine of beta. The normal pitch is useful for us to calculate the addendum and the addendum. Let's see how to draw an helical gear step by step. Let's begin with a front view of the gear. Now let's draw an unsectioned view of the gear. In this case, a profile view. If you're not going to section the gear, you must draw three thin and inclined lines to indicate that that gear is helical. In the left side, we are going to draw a sectioned profile view. This representation is the same as the spar gear we've seen in the previous lesson. The information needed in the drawing, besides the lines and the surface characteristics, tolerance, and so on, is the data table. There we must indicate the modulus, the number of teeth, the helix angle, and the helix orientation. Helical gears can be meshed in either parallel or crossed combinations. Here you can see 4 examples. For drawing the assembled gears, the representation of 2 helical gears is the same as the spar gears we've seen before. Due to the angle, we could get this representation. Another example of helical gears is the worm gear. The worm drive is formed by a worm and a worm wheel. We use this mechanism for achieving high torque and low speed gear ratio. Here you can see the representation of this worm drive. As an helical gear, it also needs a data table for the values we cannot represent as a drawing. And that's all for today. See you in the next lesson about bevel gears.